right, today we're working on learning targets. Sorry. All right, we're working on learning target sector area of a circle, okay? So what we're going to be working with today is reviewing the area formula for a circle, so how you find the area of the entire thing, but then we're also going to be talking about how to find the area of pieces of it, all right? So when we talk about a sector is a chunk of it. If you think of this entire circle as a pizza pie, and you think of this part right here that I'm shading, it's a sector, it's a piece of it. So we're going to learn how you find the area of one of those pieces, okay? Go ahead and shade that in on your own, please. That's a sector. All right, so let's start off with a quick review on how do you find the area of a circle. And if you think way back to your middle school days, here is our area formula. The area equals pi r squared. Of course, r being the radius. So what you always have to be careful of is making sure that you're using the radius and not the diameter. If you're given the diameter, you have to definitely cut it in half. Okay, so let's take a look at this example. Let's go ahead together and find the area of this circle. So I see that my radius is 9 inches. Remember, radius is half of the diameter. It goes from the center to a point on the circle. All right, I'm just going to plug it in. So area equals pi 9 squared. Now, what you need to be careful of is I want you to leave your answers in terms of pi. I'm going to write that down. That means don't actually multiply out the pi, and I'll show you what I mean. All right, so do the 9 squared, do the radius squared. So area equals 81 pi inches squared. Let's talk about what just happened. The 81 is from the 9 squared. Leaving in terms of pi means don't actually do 81 times the pi, because you're going to get an irrational number. You're going to get an ugly decimal, and then with rounding and blah, blah, blah. So leave it in terms of pi. Treat this like a variable almost. All right, so it's 81 times pi, and then our units, of course, are squared because area is unit times unit. Okay. We will come back to doing area right now, and then we're also going to do just area of pieces of circles later. So let's talk about the area of a part of it, of a sector. So remember, think about a pizza. We're going to learn how to find the area of one or multiple of these pieces. This is the formula that you need. Now, you probably already should have done arc length, and if you notice, it's very similar to arc length. All right, arc length was the arc degree divided by 360 times circumference. So here it's arc degree divided by 360 times the area being pi r squared. And once again, we're going to leave our answers in terms of pi. All right, so let's work out an example together. So we're given this circle. We're looking for the part that is shaded in, so this part right here. So the first thing we want to find out is the arc degree. Make sure you know that. Okay, so I'm looking at this arc degree right here. And I see that this is a central angle. So the arc degree is going to be the same as the angle. So the arc degree is 90 degrees. All right, and then I see that my radius is 18. So when I plug it in, it's going to be the arc degree divided by 360 times the area. Well, area is going to be 18 squared pi. All right, so I'm going to go ahead and do 90 over 360. That reduces to 1 over 4 times 324 pi. Okay, so I just divided the 90 and the 360 both by 90 because they both are divisible by that. And 18 squared is 324. So now what I'm going to do is 1 times 324. So it's 324 pi divided by 4. And I get my final answer to be 81 pi. And of course, if I'm given units, I need to put units squared. So I'm going to put a U for right now so we're getting in that habit. All right, guys, now on your calculator, all you really need to do is do 90 times 18 squared, get that answer, and then divide that whole thing by 360 and put your pi on it since we're not multiplying the pi out. All right, another example. Notice it's a very similar circle with a 90-degree angle, but this time we're finding the bigger part. I see our radius is 12. Now, this arc measure is going to be 90 degrees. Well, we want to find from here all the way around, so we're going to do our 360 minus 90 and get 270. So that's the arc measure we're working with this time. So we're going to plug it in and do 270 divided by 360 times 12 squared pi. All right, so now I have 12 squared is 144. So I want to do 270 times 144. Which gives me 38,880 and divide it by 360. And I end up getting 108 pi. Okay, so I squared my 12, multiplied it by the 270, and divided by 360. And I got 108 pi. All right, so just make sure you know which region that you are looking for and which arc measure that goes with. All right, I'm going to pause the video and I want you to try this one on your own. Okay, make sure that you find the angle measure first and then your arc measure, and then go from there. I will say, just so there's no confusion, this 8 is just from here to here. Okay, it is your radius. I'm pausing the video. All right, take a look. The arc measure is 60 degrees because if this guy over here is 120, these two are supplementary, so I did 180 minus 120, got 60. Therefore, the arc measure is 60. My radius is 8. 8 squared is 64. So 60 times 64 divided by 360, I get 10 2/3 or 10.6 repeating pi. All right, let's take a look at the next one together. All right, same thing. What you've got to be careful of here, though, is this time we're given the entire diameter. All right, we only need the radius, so we need half of that. So if the diameter is 18, what's our radius going to be? 9. All right, now, the entire shaded region is half of our circle. Well, how many degrees is half of a circle? It's 180. Okay, so when I plug it in, I have 180 over 360 times 9 squared pi. Okay, so I have 180 times 81, because that's 9 squared, pi over 360. And when I type that into my calculator, I do the 180 times 81 divided by 360, and I get 40.5 pi units squared. All right, so that is arc degree just using that formula. So all you need to find is the arc degrees itself. I'm sorry, finding sector area. That's the formula for sector area. All you need to figure out is arc degree and the radius, and be able to type things into a calculator, and you can do it. All right, let's take a look at a couple word problems together. We need to find the area of the shaded region. However, arc, we're not going to use the sector formula because that's not going to help us in this one. There's an easier way to do it. So take a look at this. First of all, they tell me AB is 6 and BC is 8. Okay. I need to find the area of the shaded region. Think of a donut, guys. We are finding the area of the outside of a donut. How are we going to go about doing that given the information we know? Well, what we want to do is we want to find the area of the entire circle, including this inside chunk. And then we want to find the area of the donut hole, so the part that someone came and popped out. And when we take those two and subtract them, we will find the area of the shaded region. So essentially what we're doing is we are doing area of big circle minus area of little circle. Okay, area of big minus the area of the little will give us this leftover part here that's shaded in, the donut part. All right, now, area of big. What is the radius of this entire circle? It is not just 8, it is this entire thing. So it is the 6 plus 8, it is 14. So it's going to be 14 squared pi, because area is pi r squared. The little circle is this guy right here, from here to here, which is 6. That's going to be minus 6 squared pi. And then we're just going to do the math. 14 squared is 196. 6 squared is 36. When I subtract the 2, I get 160 pi units squared. So that is the area of that shaded region. Big circle minus the little circle, using my area formula. All right, this next example, I'm going to pause the video and I'm going to have you try it. If you are not sure, then just wait and come back and do it with me. But for those of you that are ready for the challenge, go ahead and give it a try. Now be careful, because if you notice the little circle is not in the center. Someone who's not very good at making the donut holes. All right, it's off to the side. So make sure you fill in your radius and then go from there. So I'm going to pause the video now for those of you that are ready to try it on your own. Pause. All right, take a look. So the area of the big circle is 100 pi, okay, because my distance from A to C is my radius, because this is the center. So it's 10 squared, which is 100 times pi. Now the little circle, guys, if you notice, the radius of the big circle is the diameter of the little circle. It goes from one end to one end. So to find the radius, I have to cut that in half, and it's 5. So the little circle is 5 squared pi, which is 25 pi. And then I subtract the 2, and my area of the shaded region is 75 pi units squared. Okay, our last problem. This is a common SOL problem, all right? The center of two concentric circles, meaning a circle inside of another one, is point A. So it's telling you that they're in the center, okay? So it's kind of like that donut hole thing. If you are given that AB equals 4, so I'm going to fill in my diagram, and I'm given that BC equals 3, the directions say shade the region in the diagram below that has an area of 33 pi centimeters squared. So we need to figure out which region. So guys, there's 3 regions we're thinking of. We're thinking of the entire circle, the big circle. We are thinking of the little circle. And then we're also thinking of the donut part, which is this outside part here. Okay, and in order to find the donut part, we have to find the big and the little first. So let's find all 3 and see which one matches the 33. Don't just assume. All right, so what do we have to be careful of once again in the big circle is it's not 3 as its radius, it is 7 as both those parts together. So the big circle will be 7 squared pi, which is 49 pi centimeters squared. The little guy is right here is 4 squared pi, which is 16 pi centimeters squared. Okay, well, neither of those are 33, so don't automatically assume it's the donut. Actually do the math to make sure, because if it's not, then you went wrong somewhere, and maybe one of those really was supposed to be the 33. Okay, so to find the donut, I subtract big minus little, and that does indeed turn out to be 33 pi centimeters squared. So then I would just click and shade in here. That's lovely. All right, we are done.